Hashing function and record distribution. In hashing function record distribution, we are going to see the ways in which we can distribute the records among the addresses which is available, or the addresses in a file. So we can tell that whenever we are distributing the addresses, we can end up with different situations where we are able to uniformly distribute the records. So that is known as no synonyms. So uniform distribution. Now the second case is only synonyms, means one synonym. That is there are only synonyms, means most of the distribution ends up with synonyms in the case that collisions happens. That is the worst case. And the third one is few synonyms. In the case of few synonyms, we are having case that selected ones are successfully inserted and selected ones are having synonyms or collisions. Okay, so these are the three cases. Now we can tell that because of random generation of addresses, maximum we try to distribute our record in a fair way. Okay, but we can see that even if we use random mechanisms, we end up having problems. Okay, so as we have seen before, these are the three cases: the uniform distribution, worst case, and the acceptable case. In uniform distribution, every keys are successfully distributed among different addresses. But in the second case, so this is the uniform case. This is what we are trying to do. Now the worst case is where we end up having collisions, where are all keys A to G, every keys are assigned to the same address called 3, which is not possible and which can end up having overflow problem. Okay, now the third case is acceptable, where few keys are successfully saved inside the home address and few keys are collided with the existing home addresses. So here you can see that C is assigned in 1 and 3 in third location address, B and G is addressed, which we can tell that one is stored and one is an overflow. Similarly, here we can see 4 in 4 E is successfully stored, and in 6 also it has been successfully stored. But in the case of 10, again an overflow or collision happens, D is successfully stored and F becomes an overflow. So these are the cases which usually happens, and these worst case are the cases which have to be handled. So we are going for seeing some other techniques. In the previous class we have seen the basic simple hashing method which is used, where we end up with these three problems. So we are trying to improve our hashing methods by using or introducing some more methods. So the first one is examine key for a pattern, then fold parts of the pattern of the key, then divide the key by a number, then square the key and take the middle, that is mid square method, and then the last one is radix transformation. So the first one is using examine key for a pattern, where what we do means we try to maintain a pattern for a key and then we try to save it in a particular location. For example, we are considering an employee database where I need to save an employee and I try to maintain a particular pattern that, let it be, I am trying to save my every employees in the address which have date of birth, date of joining. Okay, so we don't have any collision because mostly we have fixed employees taken in or joined in same date. So in that case we don't have any collision. So that is a technique of pattern saving employees without any collisions. And the second case is fold parts of the key. As we have seen before, fold parts of the key is nothing but cutting part of a key, okay, and adding it. So same technique is used here. We try to extract some digits of the key which is converted into numeric, as we have seen this previous algorithm, and then we do the addition of these digits and we tell that this is the home address and we try to save our key into it. Now when we save by using this technique, we end up we destroy the original pattern of the key, but in some cases this helps us distributing the keys successfully. So this can also be a technique which is used. And the next technique is divide the key by a number. Here we try to divide the key by any number, preferably a prime number, because prime number do not have any factors, so preferably the remainder will be a unique one. So preferably the most of the cases we try to use devices which is not less than 19 and which is prime. Okay, so that we get a remainder which is unique for every keys. And the next technique is square the key and take the middle. It is not or known as mid square method. Here we try to square the key and then we try to retrieve the mid of the mid of the squared result, which is addressed or which is taken as the home address to save that particular key. So consider the example, we are having a key called 453 which have to be saved inside location starting from 0 to 99, and this is a square of 453, and now I need to retrieve the mid of my key which is nothing but 52. Now this becomes my home address for the key 453. So this is what happens in the mid square method. And the disadvantage here is we need to do a precision calculation which to find my address. So this is the only disadvantage in my mid square method. The next is radix transformation method. In radix transformation method, I try to convert my key or the numeric numbers of my key into a base which is not in the base which is the key is extended. Consider that my key is in decimal base. In that case, I try to convert it into another base. Okay, and after that, what do I do? Means I do the mode with a mode of that result with a maximum address. Means the maximum address, the addresses which is a maximum address space which is available for putting that particular key. Then we get the hash address. So we'll see an example here. Consider that 453 is a decimal number of your key, and we can try to convert it into another base like level. So now you get 382. Now we need to do the mode of this with 99, where 99 is a maximum address available for me to place my key. So now when we do 382 mode 99, we get 85. So we can tell that this is also a random and another random technique which helps me give a very good results compared to my mid square method which you have seen before. Next we go for the prediction of distribution of records, and another technique which can again help us. Okay, in this technique we just see a function called Poisson function which introduces some techniques where we can use. Here we are considering n as the addresses in the file, means 0 to 99 addresses. Now the two outcomes when I do processing of a key using hash function is I have A known as addresses not chosen and B known as addresses chosen. Okay, and then we can calculate the probability, like P of A is the probability of address not chosen, then P of B is the address chosen, and then we can calculate again B is equal to 1 by n, that is the addresses chosen, and address not chosen is 1 minus 1 by n, which is found from n minus 1 divided by n. So this is again an example. If we consider 10 addresses and I am trying to find the value of A, B, okay, you have seen B is the address chosen with 0.1, not chosen is 0.9, and again I am considering another cases like if two keys are hashed, if it is whether it is assigned properly to its home addresses. For that I am calculating probability of B and B, that is probability of placing these two keys inside the home address, that is P of B and B. So it is B into B, that is 1 by n into 1 by n, that is equal to 0.7. And the next case is considering that one is placed successfully in the home address and one is not placed. That is why P of B into A. So that is 1 by n into 1 into 1 by 1 minus, okay, and so we get 1.9. So we have seen in Poisson distribution we can or function we can see that we have a series of functions where we come across the main formula P of x is equal to C is equal to C of 1 minus 1 by n r minus x 1 by n, where n is nothing but P of x is nothing but the Poisson function, n is the addresses available, r are the keys which we need to hash, x is the probability of address chosen, and x minus r is the probability of address not chosen. So this is the function which is again used here, and by using this function we again are able to find how many addresses are or how many records are placed in the home address Okay, whether how many number of collisions happens in address. Okay, these and all can be found by using Poisson function. For that we can use n into p of x, which is n is the number of addresses and x represents the number of records placed. So this gives you the number of records placed in one address. Similarly, we'll be going to see. So consider p of 0. It case that gives you the probability that not 0 records are placed in addresses. Okay, so p of 0 represents 0 records placed in a address. So this is how it is for p of 0 means 0 records placed. P of 1 means 1 record placed in an address. Again, p of 2 means it is p of 2. P of 2 means it is 2 records placed in a record in a address. So we can see that whenever we are finding the probability, it keeps reducing because the overflow records are being now placed inside the home address. So we can tell that by using this technique of Poisson function, we are able to handle our overflow record. Thank you.